All right, welcome to today's revision session on inclined planes. We're going to do a few questions here, about half an hour's worth of revision. Here's our first question. I'm going to give you, let's just give you 3 minutes to warm yourselves up with start this question. Okay, so that's 3 minutes. Sound out here to through 1, 2. Oh, yeah, I've got to just get close to the microphone. Okay, right. So that's the 3 minutes up. If we draw this picture, so let's just get our. I'm going to create an inclined plane using this funny triangle shape here. Nice, easy one for me to do. And I'm going to get myself a particle. So here we go, and it's got a mass of 5 kg. So acting down, we'll have 5g. Let's just change that kg to just g. We'll have a normal reaction, perpendicular to the plane. We know that it's inclined at 30 degrees to the horizontal. So we want to find the normal contact force between the plane and the particle. We know it's accelerate. Well, we're going to take our acceleration this way. And if we resolve perpendicular to the plane, then we get R will equal 5g. And if we put the angle in here, it's going to be this part of it's going to be the adjacent part, so it's going to be 5g cos of 30. Okay, so that's equal to 5 times root 3 over 2g. Taking g as 10 meters per second, work that all out, we get 43.3 newtons. Now for part B, we need to find the acceleration, so we're going to resolve parallel to the plane. So we've got MA, so we've got 5A will equal, now the G is going down the plane, so it's going to be minus 5G sine 30. And that cancels out with that, so it just means that A comes out to be half G, which is going to be minus 5 meters per second squared going down the plane. So we know that A equals minus 5 and U equals 20 and that T equals 2. So using S equals a UT plus a half AT squared, we get UT is going to be 40 plus a half times minus 5 times 4, T squared is 4. And that comes out to be 30 meters. Right, our second question. So what we'll do is we'll give you, judging by the speed we did that in class, we're going to give you another 3.5 minutes to do that question. So 3.5 minutes, off you go. Zoom this in a bit as you watch. Feel free to use 9.8 as G. If it's not given in the question, use 9.8. Because all the questions I use 9.8 unless it's given in the question as something different. Right, okay, so that's enough time to have a go at that one. Let's just draw our plane in. So I'll just get myself a shape that looks a bit like an inclined plane. Here we go. And what we got? We've got a child of mass 30 kilograms sliding down at an angle of 40 degrees to the horizontal. So this is 40 degrees. And we've got mg acting down. So that's 30g. So let's just replace that m with a 30. And we got a normal reaction. And that's going to be r. And we'll have friction acting up the plane. And we're going to find the normal contact force between the slide and the child. So what we're going to do, we're going to resolve perpendicular to the plane. And what we will get is we'll get that R will equal 30g cos of 40. Okay, 40. And we can see that the perpendicular part is adjacent, so we get 30g cos of 40. And that will come out to be 225 newtons. You've multiplied that all out. Now, moving on to part B. We want to find the acceleration as the slide is smooth. So therefore, if we were to resolve, and we've got the coefficient of 0.1. Well, let's just do smooth first. So therefore, it's going to be accelerating this way. And we're going to basically, there's no friction here. We're just going to have all the weight giving us acceleration. So the mass times acceleration, 30 times A, will equal to this component of the weight. So it's going to equal 30g sine of 40. Now if we work that out, just get that. So we get A equals g times the sine of 40, which comes out to be 6.3 meters per second squared. Part 2. We resolve this and we've got friction, so we're going to have 30A will equal 30g sine of 40 minus the friction. Okay, so we've got minus friction. And we know that F equals mu r. The friction equals mu times r. And we know that mu in this question is 0.1, so we've got 30A equals 30g sine of 40 minus 0.1 times the normal reaction, which was 225. And if we work all that out, what we should do is we should get A is equal to 5.5. meters per second squared. Right, next question. Okay, question 3. Let's get that on the screen. Here we go. Block of B, mass 1 kilogram. I think this is going to be a bit more involved and a bit longer. Let's work out how much time we're going to give you on this. I think the pulley, this is at least, okay, I think this is a good 6 minutes I'm going to give you on this one to do. So 6 minutes starting from So I just realised it hasn't got the whole question. I'm going to grab you the actual question part. You should hopefully have drawn the diagram at this moment in time. I'm just going to get you the question bit and just paste that in there. There you go. There's the actual part, the question part. Okay, so hopefully you've spent your time drawing the diagram and now you're ready to do the question. Right, that's the 6 minutes up now. So let's go through this question. Right, we're going to draw a little diagram. So let's do some lines. I'm going to have a straight line here. I'm just going to put another straight line here. I'm going to put my little sort of pulley type shape here. And so I'm going to have another rope on the block pulling that way. I'm going to have weight 1g going down that way. I'm going to have my normal reaction going that way and my tension going that way. On this block, I've got 2g going down and it's a height of 1 meter above the ground. I've got my tension pulling that way and my tension pulling that way. It's on a smooth plane, so there's no friction. Now we know that this is 35 degrees to the horizontal. So therefore this will be 35 degrees as well. Because if you think about that little angle in there, I know I made it quite small, it's 35, therefore that's 90 minus 35, therefore this will be 35. So let's resolve parallel to the plane on, was it the 1g parallel to our plane. So we're going to have MA, so M is equal to 1, so get rid of the M. So we have A will equal, or I'm going to write 1A just to remind ourselves, is going to be equal to everything in the same direction as acceleration, because we're going to assume it accelerates this way, because this weight's heavier and it's pulling it up. And we're going to have the tension pulling, and we're going to have minus the 1g times the sine of 35. It's the opposite side. So we're going to have g sine 35 acting against the tension. Now we're going to resolve on the 2g, and we're going to do that vertically downwards, because it's going to be accelerating this way, so we might as well do it. So everything's positive in this direction. So we're going to get 2a, m times 2a, because it's going to be m times a, is our resultant force. And the resultant force is the resultant of the 2g acting down minus the t acting up. And we've got two equations, 1 and 2. Now if we add those two equations together, so we get equation 2 plus equation 1, we get 2a plus 1a plus 2a is 3a. And we get the t's cancelling. T minus t is 0. So we're going to get 2g, and then we're going to add this minus g sine 35 over here. So the acceleration will equal 2g minus g sine 35, all divided by 3, which comes out to about 4.66 meters per second squared when we calculated that. Let's just give ourselves a bit more space to complete this question. So we want to, sorry, I've gone past it, haven't I? Let's put some space there. Right, so when P hits the floor, the string breaks. So this is going to continue to accelerate. It's going to continue with this acceleration until it hits the floor. So for 1 meter, it's going to accelerate with 4 meters, A equal to 4.66. So we know that S is equal to 1. We know the starting velocity, because it's released from rest, is equal to 0. We don't know the velocity when it hits the ground. We do know the acceleration is equal to 4.66. So we're going to use v squared equals u squared plus 2as. So v squared will equal, use 0, 2 times a times s. S is 1, so it's just going to be 2 times the 4.66. Use your full calculator value here. And when you've worked that all out and you square rooted it, we get v equal to 3.05 meters per second. Now, assume initial distance between the block and the peg is sufficiently great the block will not reach the peg here. Find the total distance travelled by the block when it instantaneously passes through its initial position. So first of all, what we need to do is we've got to work out the acceleration. Okay, and then we've got to work out when it gets back, what it's going to get back to when it gets back to its initial position. So what we've got here, let's just think about this. Well, actually, let's do the resultant. Let's find the acceleration first on this block, because it's now got no tension in the string. It's just got the 1g acting downwards and the normal reaction here. So all the acceleration is going to be that way, and it's going to be given by 1g and this is 35 in here. So it's going to be 1g sine 35. So we've got 1a will equal g sine 35. So a now will equal g sine 35, which comes out to be minus 5.62 meters per second squared. Okay. Now, we have basically, at this point here, after it's traveled 1 meter, okay, it has, at this point, the velocity equal to the velocity I found here. So it's we've got a u position equal to 3.05. We've got an a equal to minus 5.62 at this point. And we want to find out when it gets back to its original position. So where s is equal to minus 1 meter is the easiest way to do this. So we can use v squared equals u squared plus 2as, because I think it was the velocity it wanted us to find, didn't it? Oh no, find the total distance travelled by the block when it instantly passes through its initial position. Okay, so we're not going to do that. I misread that. So I thought it wanted the velocity when it gets past. What we need to do is just find out how far it goes up the plane before it turns. And then once we found that distance, we'll now be able to add on the distance coming back down the plane quite easily. So we need to find out where v equals 0, because that's how far it's going to go up the plane, and then it's going to turn and it's going to start falling back down the plane. So we've got v equals 0, we've got a, and we've got u. So let's use v squared equals u squared plus 2as again. We know v equals 0, and we know u equals 3.05 squared. We know that a is negative, so we get 2 times minus 5.62 times s. So s will equal 3.05 squared over 2 times 5.62. So I'm getting a bit behind my logo in my head. I'll just move that. And that comes out to be equal to 0.829. So that's how far it's going to go up the plane. So the distance it's travelled up the slope is now going to be 1.829, and therefore the total distance travelled will be twice that. So we want the total distance will equal 2 times 1.829, which comes out to be 3.66 meters. Right, that was quite a tricky question, really, because, well, not tricky in itself. It just had to be very careful about how you went about doing your maths. Let me just scroll that up away from my logo. Right, I think we've got time, just one more of these questions. So let's have a go at this question 4. I'll just zoom in a little bit, and I'm going to give you trying to work out if you find my previous doing of. I can't find it. So I'm going to guess that it's going to be about a 5-minute. Okay, so I'll give you 5 minutes to have a go at this, especially after all the chat I've given you. Right, I'm just going to give you an extra minute just to finish that off. I think it's taking longer than that. Okay, let's go through this question. So what we got here is we've got our tension acting up the plane that way. Now it's on the point of slipping down the plane, so its friction resists motion, so the friction will act up the plane. We have a normal reaction perpendicular, and we have the weight acting this way. So we know that that angle there is 24, and this angle is 38. Now what I'm going to do is I'm going to resolve perpendicular to the plane first. Okay, so I'm going to resolve perpendicular to the plane. So I'm going to have R plus this bit of T. So I'm going to have plus T sine of 38. And that will be equal to this bit of the weight. Okay, because we're in equilibrium, everything on one side must equal everything on the other side. So we're going to have 4.5 times G times cos of 24. It's the cos bit here. Now, this is where people who just automatically assume that R equals mg cos theta, because a lot of people remember that because it often comes out that way, get unstuck because the T happens to act perpendicular to the plane as well. Now, what happens in lots of questions, it doesn't. So therefore, it's always mg cos theta. But it's not in cases where there's another force acting not parallel to the plane. So we've got that for our R. And what we could, well, when you're setting up the problem, it's best to just set up all the things you know when you're not sure what's going on. So we're going to resolve parallel to the plane. So what we've got is we've got the 4.5 G times sine of 24 acting down the plane here. And that's going to equal the FR plus the T cos of 38. So we get FR plus T cos of 38. Now, what we've got is we've got R, T, and FR, but we also know that FR, the friction, equals mu R. So if we rearrange this to go into here, because we've got mu is 30, we can then find out what F, the friction is, and put it into here, and then we can find out T. So let's do that. I'm just going to scroll down, give myself a little bit more space. So I'm going to have the friction will equal to 0.3 times the normal reaction, which is going to be 4.5 G cos 24 minus T sine 38. Now this is where it might go a little bit wrong because I haven't been able to check my calculations that I did on my calculator just now because I've mislaid where the answers were. So I just done this just now live, and I got I just spotted a mistake already in my answers, so that's lucky. So what we're going to do is we're going to work out 0.3 times all of that. So I'm going to do 0.3 times the 4.5 times the 9.8 times cos of 24. And I'm going to get 12.086 and so on. And then I'm going to have minus t sine 38 times 0.3. Actually, what I'm going to do is I'm just going to leave 0.3 t sine 38 in there for now, and then substitute this all into this equation here. If I call that, if that was equation 1, that was equation 2, and I've got down to equation 3, I'm going to put 3 into equation 2. So 3 into equation 2. So I'm going to replace the FR here with all of this. So I'm going to get 4.5 G sine 24. Basically, mechanics is all about how good your simultaneous equations are, because that's the only way they can make the problems harder once they've set them up. So I'm going to put all of that in. And the mistake I made was, actually, if you must know, is I forgot to times the 0.3 here in my answer I just did while you guys were working on this. So here we go, we get that. So I'm going to take this away, work this out and take this away, and that comes out, when I've done all that, to be 28.2 roughly. And that's going to equal, let's just factorize out the t. So we're going to get t, and I'm going to have cos of 38 minus 0.3 times sine of 38. So t will equal the 28.2 divided by cos of 38 minus 0.3 sine of 38. And I'll just work that out for completeness for you. I'm just going to get it's 28 point. I'm just going to write down the digits because it's going to go off my screen. I did work out the 28.20114 828, and I'm going to do that 28.21148. Always use your full calculator display when doing calculators. I'm going to do divide by open brackets. We've got cos of 38 minus 0.3 times, I didn't do the 0.3 for some reason, 0.3 times sine of 38 equals, I should get an answer. And I got 46.7 newtons for that. The 3 significant figures. Now, if you can do this and the last question, you pretty much have got inclined planes cracked, especially with basic pulley questions like we had in the last one. So back tomorrow, we'll do some more equilibrium problems tomorrow, and hopefully that'll just be a little short half-an-hour lesson. Thank you.